Hi, bear with me. This is my first talk ever, and I actually completely rewrote it yesterday. So let's. Yeah. So I originally wanted to actually talk to you about my love of Conlet and how I think Conlet should be part of Clojure Core, but I was told that this was too boring. So instead, we're going to talk about fashion. And this doesn't work. So yeah, the reason we're talking about fashion, well, professionally, I'm a model. This is me looking very grumpy a few days ago while trying to balance a bag and perfume on one leg. And as we all know, modeling and coding have a super long and closely connected history. So, but what you might not know is this, before this, I was a Clojure developer in Berlin for 4 years. And I mainly focused on building back-end applications from scratch using Datomic. And I don't know if you guys had these little like bingo cards yesterday, but I noticed that on some of them there's a slot that says learned Clojure as your first language, and you can fill my name in because that was me. I've since dabbled in other languages, such as Python. At my old job, I used for Universal Robots, but I'm lucky enough to say that about 90% of my time was spent with Clojure and Datomic. But currently, I spend a lot of my time surrounded by people in fashion, thinking about clothes, etc. And but yeah, what does this have to do with people not in the fashion industry? So can I see a show of hands of who's seen the movie Devil Wears Prada? Cool, a lot of people, great. So it's kind of a modern day classic, but I think that Meryl Streep's character actually sums up like how does fashion relate to people not in the fashion industry very well. There's this scene in the movie, for those of you that haven't seen it, where her character, who is the editor of Vogue, she's supposed to be Anna Wintour, and Anne Hathaway is the new journalist. She's like started working there. She doesn't give a shit about fashion. And she is laughing at how they're arguing over two belts that look essentially identical. And Meryl Streep's character is like, what's funny about this? And she starts kind of going off about Anne Hathaway's sweater. And she's like, you know, I don't know if you noticed that sweater. It's not just blue. It's not turquoise. It's not lapis. It's actually cerulean. And it's like, why does this matter? And she kind of traces the history of using this color from an Oscar de la Renta like 2002 collection and how it trickled down through various designers and brands till it got to the high street store she bought it from. And you're like, okay, but what about me? How does this relate to me? Well, I see a lot of you wearing Clojure t-shirts or other programming t-shirts out there. But did you ever wonder where logo t-shirts came from? I mean, these people not wearing logo t-shirts, so obviously they had to start at some point. So I asked a friend of mine who studies fashion, who recently did a study on the origins of these 2018 Dior slogan tees, which kind of had a little bit of a controversy. And I was like, when did logo t-shirts start? So they originally started off, they're a little bit different than slogan t-shirts, but the idea of wearing a brand across your chest was popularized in the late 80s and early 90s during the logo mania trend, which is widely credited to this guy, Dapper Dan, who had a made-to-order shop in Harlem. And he created bootleg branded t-shirts and shoes and bags from designer goods and sold them to rappers, athletes, drug dealers, I don't know. And after that, the trend blew up. And so, and this, you know, essentially like you're not wearing like, you know, high fashion, like Louis Vuitton written across your chest, but you're still wearing like your brand, essentially. So this issue, though, of who started a trend is a really big issue, or is a really big question in fashion. There's this Instagram account called Diet Prada, has 1.5 million followers, and it's completely dedicated to showing people knocking each other off, like designers copying each other, etc. So some of these looks obviously copycats like this and this, you know, it's like the same thing. But some of them, a little bit more difficult to tell what exactly is the same here. I mean, when I saw this, my reaction was more along the lines of this commenter. Yeah, so, and like, are these people really copying each other? Because, I don't know, it's literally just a skirt and a shirt. And I was like thinking to myself, isn't this a question that machine learning, and specifically computer vision, could answer for us? Because even the most well-learned person in fashion studies can't possibly remember every look from every designer from every season. And I actually think that there's like interesting implications for the knockoff industry as a whole. So I started looking at like, how is machine learning being used in fashion now? So most of the articles I found had lines like this. Machine learning is being used to maximize users' shopping experience, improve the efficiency of sales systems through intelligent automation, enhance the sales processes, and make the supply chain more efficient. all of this is geared towards selling things, making selling more efficient. So one example of this, Stitch Fix. Stitch Fix is an online personal styling service which sends its 2.7 million active American clients suggestion boxes of clothes chosen by cross-referencing a client's stated preferences with the recent purchases of others of similar age and demographic. They're also a company that puts a lot of mathy pictures on their website to intimidate people. But I read their algorithm description, and basically they're just using a collaborative filtering model, which, for those of you who don't know, is the most basic model for a recommendation system. And it's based on the assumption that people are into the same kinds of things as other people who are like them. Okay, next we've got the extremely depressing Amazon Echo look, which I don't know if you can see it sitting on her dresser there, but this device takes a photo of you and then uses machine learning to analyze your outfit and score how you look, which is like this. It's horrible. But yeah, early test users report that it scored navy and muted colors higher than brighter shades and gave the thumbs up to Instagram-approved styling accents, such as popped collars and rolled-up shirt sleeves. So basically, it scores high for conformity. So I'm sitting there and I'm like, this isn't what fashion's about. I mean, at least not to me. I mean, it's Stitch Fix is sending you clothes to make you look like other people in your demographic. The Amazon Echo look is encouraging you to dress like whatever is trending on Instagram. Is this fashion? I mean, when I think of fashion, I think of this. You're not going to wear that, especially not that dress in the middle. But, and like, or this. You don't wear this. This is art. This is meant to inspire and like change clothes on like a fundamental level. I mean, maybe what you would see in sort of an everyday, like maybe blue mesh will become a trend. I don't know. But you're definitely probably not wearing this out on the street. So I was reading this great book recently called The Creativity Code by Oxford mathematician Marcus du Sautoy about the current applications of AI to the arts. And interestingly, he actually talks about like, how is AI being used in music? How is it being used in art? And how is it being used in mathematics, which is a creative subject, but he never mentions fashion. But anyway, he goes over 3 types of creativity. The first one is exploratory, which involves exploring the outer edges of what is already there. Sorry, I'm really thirsty. The next one, combinational. An artist might take 2 different existing constructs and combine them. And the third, transformational, which is those like rare game changer moments when something really like completely shifts a discipline. So how does machine learning help us identify this? Du Sautoy cites a 2015 paper titled Quantifying Creativity in Art Networks, in which Ahmed Elgamel and the Rutgers Art and AI Lab trained a neural network on over 62,000 paintings in order to see if they could create a computer algorithm that quantifies the creativity of a painting. Could this algorithm identify, say, moments of real transformational creativity? And this is like paintings over the years and the creativity scores on the left-hand side. And it turns out it could. One of the paintings that it scored very high for creativity was Picasso's Les Demoiselles d'Avignon. It's really messed up because I live in Paris and I still can't speak French at all. But this is interesting because whatever your personal feelings are about Picasso, this painting is widely regarded by experts as revolutionary, and it was like it worked in the algorithm, like had a very high creativity score. But back to fashion. It's clearly a really emotional issue, the origins of a trend. But how do we study this? We need a big data set like Ahmed Elgamel's 62,000 paintings. For e-commerce, we have this. Zalando released Fashion MNIST. It has a 70,000 image data set of labeled grayscale e-commerce images, which is intended as a replacement for MNIST, which I hope I'm saying correctly. Oh my God, that's my mother texting me, sorry. Which I don't know if you know what MNIST is, but it's a database of handwritten digits. That's the classic data set used to train image classification systems on. But what do we have for high fashion? I mean, how can we study any of these actual looks? Well, actually, we do have this data set. Vogue Runway, which posts the looks from every season for the top 1.5 thousand designers, which gives us a very large total data set. But at this point, you're wondering, why is she talking about this at a Clojure conference? And also, why bother doing any of this in Clojure when the predominant language for machine learning is Python? I mean, there's a reason everyone uses Python. It's like vast adoption. It means that it's stable, it has good tooling, and it has a wide support community. But why Clojure? Aside from my personal history where I used it for 4 years, so obviously I'm a little bit partial, I watched a really great talk by Joyce Zhu, I hope I'm saying her name correctly, who came from a Python background in machine learning, but she was so she had to use Clojure for a project at work, and she was so convinced by its application to machine learning that she gave a talk at a Clojure conference arguing for it. I would highly recommend her talk. I'm not going to go through everything she said, but to sum up her arguments, neural networks are a series of function transformations, essentially, and this can be closely paralleled by a threading macro, and that the entire machine learning pipeline itself is performed as a set of composed functions. Direct quote from her, "Even outside of Clojure, it is most clean, elegant, and effective to write this pipeline in a functional manner." So I started trying to learn about machine learning, and I took this course online called Fast AI's Practical Deep Learning for Coders by Jeremy Howard. Also would highly recommend. It's written in Python using the Fast AI library. And this is an example of the code from his library. It's an example of how to use the data bunch class. And you can see here it's a pipeline of things that dot into each other. During the course, Jeremy's like, this actually isn't so common of a pattern in Python. So he's creating this API that utilizes a pipeline in a language that's generally not designed for it because that's the most elegant way of handling the data. But this kind of pattern is how we use Clojure. This is functional programming. So why not use it for machine learning? Is it enough when a language conceptually is a good fit for a domain? So I tried to answer this. I also stole this slide from Joyce Zhu's talk. So this is the machine learning pipeline. So the first part of the pipeline, data loading and transformations. Here, this, interestingly written. Basically, it turns out that Vogue API has a GraphQL. So I could easily query the data I wanted using this library. And you could see, you go through it. This is basically just per brand. It's also, I'm going to put the code up somewhere later, so that if you are interested in using this data set, you can do it like all designers, et cetera. But this one per brand, you go through the fashion shows. It filters by just the images that are for the collection, not detail images, which is what you're looking for. And here's an example. Output, you get your slug, season, images, et cetera. Work like a charm. So far, so good. What about the model part? Can we do this in Clojure? So here I chose to go with the Clojure wrapper written by Karen Meyer for the Scala API of Apache MXNet. And this is an example from her example set for just a simple image classification model. I find this extremely easy to read, but you can also see here Joyce Zhu's point about neural networks as a series of function transformations. There is the pipeline. There you go. But what we're actually trying to do and get is to run data on that model. And this is where I ran into some problems. My MacBook Air's pitiful 8 gigabytes of RAM really wasn't working for me to run anything on. So I was like, okay, I have to get a virtual machine running. It took me 3 days to get this running on Google Compute Engine. And you're like, why? Why the hell would it take you 3 days to get this setting up? So these are the dependencies, the exact specific dependencies that you need. Maven, Scala, OpenTheme, blah, blah, this. And you're like, okay, fine, still not that many. Why not just install the dependencies? Yeah, I did this 4 times because maybe at first I found this Google image, which was called MX latest CU92, experimental. And you're like, okay, this probably has most of my dependencies that I need pre-installed. It's definitely got the first one, CUDA 9.2. Did this and tried to install everything else on it, got all these crazy errors, and I was like, what is wrong? Turns out that OpenCV 3.4 only works on Ubuntu, not Debian, which this is built on. So I was like, okay, great, I have to do this all over. So I redid the entire thing from scratch on Ubuntu 18. That doesn't work either because it only works on Ubuntu 16. And there was pretty much no documentation for this anywhere. I just had to do trial and error to figure out what worked. And then after this, you have to use just the snapshot version because the thing that's actually up on master still doesn't work. So after 3 days, I finally have this up and running. Kind of annoying. You're like, I don't know, anybody that's tried to use Apache MXNet might have seen that there is a pre-built image for Amazon Web Services. So like, why bother doing this on Google Cloud instead of just using this like much easier to use Amazon Web Services image? Well, which by the way, I put all the instructions for how to do that on Google Cloud on a gist, which I'll share so nobody has to do that again. But yeah, Google Cloud is actually cheaper overall, and it has fixed pricing instead of variable pricing. With like Amazon Web Services, you have to bid for a spot instance, and it can shut off. And Google Cloud charges per minute instead of per hour. And the most importantly, you get a $300 free credit, which to me, I'm sorry, this is a hobby project, and I'm not going to spend $100 on it if I don't have to. So yeah, after all this setup, which was kind of a pain, I'm like, now does it work? Is it enough, like, for this to conceptually fit? No. Why? Because after this, I ran into a really crazy memory problem where no matter what I did, threw different hardware at it, like a bigger GPU, multiple GPUs, etc., I just ran out of memory and it crashed, and which I clearly forgot to put this screenshot for that in there. So yeah. But after this, and I'm like, okay, this shouldn't have been this difficult to debug. But I scoured the issues in the project. No one had a similar problem. I looked in the Clojurian Slack group, and there are, in the MXNet channel, 3 posts total. So I was like, okay, I probably feel a little bit intimidated writing in here. And then I reached out to Karen Meyer, and she was so nice and really helped me out. But I'd already reached out to her twice, and I don't want to put all of my problems on her. So yeah, to answer the questions like, can Clojure wear Prada? I mean, yes, it can, but there's like a little bit of work to do. And I think it's super important. I think with any of these new tools, we need a community. Otherwise, it's going to discourage people. Like if you have setup problems like this, like I don't know, honestly, if I didn't have this conference, if I would have bothered trying to do all of this. So yeah. That's basically it. I hope at the very end of this I will inspire some of you to think about the application of machine learning to fashion in a different way. And if any of you are interested in like trying to work on this with me, that would be cool. And I just hope that we can get more people using this, because I do think that there is a great use case for Clojure for machine learning. I do not use Twitter. If you want to follow me on Instagram, you can feel free. And there's my GitHub. And that's basically it. So thank you.